first name is
Oh, man.
Schaefer. He graduated last year. I heard it was because he went to foreign exchange.
Oh,
What
man.
happened?
Okay, I got to record.
Some people who do foreign exchange.
Okay, everybody, here we go. I'm going to recap the lesson.
That's only if you fail the class.
So, we're going to look at rational functions in standard form. First of all, the best way to look at it is fx equals a, which is a number, over x minus c, which is a number, plus d. We've learned a few things. First of all, we know that x cannot be c. Therefore, we know that we'll have the vertical asymptote at the value of c. We also know that the value of d is where our horizontal asymptote is, and then value of a is where we get the width of the graph, and the width of the graph tells us all of the points. Okay, so then what we did is we took a look at an example. Okay, fx equals 6 over x minus 2 minus 3. So first of all, I know that this value, x cannot equal negative 2, because negative 2 plus 2 is 0. If we divide by 0, it's going to be undefined, or it goes to infinity. So I also know then my vertical asymptote is at x equals negative 2. This number is my horizontal asymptote at y equals 3. Now, when I want to graph this, I'm looking at the values of 6. Now, the entire graph got moved to here. So instead of it being graphed at the origin, the graph got moved to here. So then we looked at all the multiples of 6. Well, 6 times 1, 3 times 2, 2 times 3, and we graphed all of the points in. Of course, the negatives. We graphed the negatives also. Negative 6 times negative 1, negative 1 times negative 6, negative 3 times 2, negative 2 times negative 3, and we graph that in. Okay, so there's my graph, there's my function. We know we have a vertical asymptote at negative 2, and we have a horizontal asymptote at negative 3. Then we talked about end behavior. As x goes to infinity, then the y value is approaching negative 3. As x goes to negative infinity, again the y value is going to negative 3. We talked about what happens when x gets close to negative 2, y goes to infinity. Or on the other side, as x gets closer to negative 2, then y goes to negative infinity. Okay? We talked about domain and range. The domain is all the x values. So in this case, it's all the x values. It's all real numbers except it cannot equal negative 2. We talked about the range, which is all the y values. In this example, y can be all real numbers except y cannot equal negative 3. Okay? Now, finally, we talked about the x-intercepts, or the y-intercepts. To find a y-intercept, we just let x equal 0. We plug 0 in to the equation, and we solve. Okay? Now, we also looked at a couple of examples in class. We took the parent function, and in this example, we knew we had to take it up to 5. We brought the parent function up to 5. It changed its range, where y cannot be 5. Okay? We took a look at this parent function. We knew that we had to take it to the left 5, because it's always the opposite inside. So we bumped the graph over 5 and put our parent function in. It affected the domain. X cannot equal negative 5. Okay, then finally, we looked at ones like this. So they tell us where our vertical asymptote is. 2. Horizontal asymptote is at 1. Here's our graph. Our function can be, sorry about that, can be a 1 over x minus 2 plus 1. And then we looked at a real funky graph that has 2 different asymptotes. We know that it has a vertical at 1 and at negative 5, a horizontal at negative 3. We came up with an equation, x minus 1, because x cannot equal 1, x plus 5, because x cannot equal negative 5, and we knew that it was bumped up or down to negative 3, so there's my d value. Okay? And then this one, it said take it to the right 2, because it's the opposite, and down 4. We know the function has to look like this. We knew the equation would be a 1 over x minus 2 because it cannot equal 2, and then minus 4. Okay? Finally, I gave for homework this page, and I asked them to go ahead and graph A, B, C, and go ahead and do the rest of the work. Okay, so that's all I have. Homework was page 405. Okay, there we go.